Hello student, welcome back to lecture series on Fourier transform. Already we have started lecture series based on Fourier sine, cosine, Fourier and their inverse transform. So if you are interested to see this video, do check in my playlist. So in my today's video, I'm going to explain to you all some of the question based on the Fourier sine, cosine transform. Okay, so in such a question, we have to find out the integral. Okay, we have to find out the integral equation. But see that it is not mentioned here anywhere in our question that to apply Fourier sine transform or Fourier cosine transform, that we have to figure it out, which we have to apply, okay, by observing our given integral, okay, given integral, and we have to find out the solve integral equation. Such a question asked plenty of the time, such a question asked in your previous year Sppu question paper. So guys, these are important question. Okay, so let's get started today's example. I will explain to you all how can we solve this one. Okay, now see that as we have integral 0 to infinity f of x sin sx dx e raised to minus s. Okay, so as we can see 0 to infinity means, that means we cannot apply Fourier transform, as we have minus infinity it is present in Fourier. Okay, so we cannot apply Fourier cosine also because we don't have cos, so it is left only the chance for sine. Okay, so we apply Fourier sine transformation for solving this integral. Now see that 0 to infinity f of x sin sx dx. Okay, so we apply here Fourier sine transform to solve this integral. Okay, yes, but now see that which we have to apply, Fourier sine transform or Fourier cosine transform, sorry, Fourier sine transform or inverse Fourier sine transform. Okay, let me write formula for we all. Okay, so once we understand the formula, then it is easier to solve this one. Okay, yes, so Fourier transform, what it says that Fourier transform capital F. Okay, capital F, this one is a capital F, and suffix s means it is a Fourier sine transform over s. Okay, Fourier sine transform over s. We write this one as integral 0 to infinity small f of x. Small f of x is a inverse Fourier transform. Okay, small f of x sin sx dx, sin sx dx. Okay, this one is our Fourier sine transform. Okay, this one is the formula for Fourier sine transform. Now we are going to compare this formula with this example. Okay, now see that f of x, small f of x is there, 0 to infinity integral it is also there, sin sx it is also there, and dx it is also there. That means if we compare both of the side, we get the Fourier sine transform over s as e raised to minus s. What we get here? Fourier sine transform over s, we get e raised to minus s. Just need to compare these two sides. Okay, so once you get the comparison from both of these sides, you will get this one. Okay, Fourier sine transform over s, which is e raised to minus s. Okay, now I got the Fourier sine transform value for Fourier sine transform. Now we have to solve this integral, then that means we have the remaining, okay, left the formula, which is a Fourier inverse Fourier sine transform. Okay, so if we apply inverse Fourier transform, inverse Fourier sine transform, so easily we can solve this integral. Okay, so now see that how I am going to apply inverse Fourier sine transform. Okay, so what is the formula for inverse Fourier sine transform? Let me write inverse Fourier sine transform. Okay, we are going to apply here inverse Fourier sine transform, and it can be written as small f of x, which is equal to 2 divided by pi integral over 0 to infinity. Okay, integral over 0 to infinity Fourier, that means this Fourier sine. Okay, Fourier capital F, Fourier sine transform sin sx dx. Okay, sin sx ds. Okay, now always remember that whenever we have inverse Fourier transform small f of x, we apply dx, and when we have Fourier sine transform fs over s, we apply ds. Okay, so this is the integral, so you have to take integration here with respect to dx, and you have to take integration here with respect to ds. Okay, now we have to solve this integral. Okay, we have to solve this integral. That means substitute all these values here, you will get the simplified form of our given integral. Okay, yes, so we write the value 2 divided by pi. Okay, integration over 0 to infinity, capital F of sub s of s, that means Fourier sine transform over s, we have e raised to minus s. Okay, e raised to minus s, and the sine s x ds. Okay, e raised to minus s sine sx dx. This is just the replacement of values in our Fourier sine and inverse Fourier sine transform. Okay, yes, now guys, see that what you all do, just recite all these formulas. 2 formulas for Fourier sine transform, 2 formulas for Fourier cosine transform, and 2 formulas for Fourier transform. These are helpful for solving the examples. Okay, yes, okay, so now see that we got the small f of x as a 2 by pi e raised to minus s into sine sx ds. Okay, yes, so we are going to solve this one further. Okay, so as we know that we have one of the standard integral, which is e raised to as sine s x. Okay, sine sx dx. So as we are taking integral in the form of ds, we have to apply that formula in the form of ds. Okay, let me write the formula. E raised to as, okay, integral over e raised to as sine bx dx. Okay, sine bx dx. I'm going to apply this formula over here. Okay, sine bx dx can be written as e raised to ax upon a square plus b square, a sine bx minus b cos bx. Okay, this one is the replacement of formula. That means we have to replace this integration under this one. Okay, so now see that, compare both of the sides. Okay, e raised to minus, okay, just compare both of the side and replace the values. Okay, e raised to ax, this one, e raised to x sine bx dx can be written as e raised to x a square up plus b square, a sine bx minus b cos bx. So take these values here. So I'm going to write these values here. Okay, it is quite easier, guys, just need to replace the values. Integration of e raised to minus s, that means e raised to minus 1 into s sine bs ds. Okay, sine bs ds, that means I replace this one, these values here. Okay, that means bs, just what we have value here, we have the value for bs. Now see that why I have written bs instead of sx, because I just want to compare the value. Okay, bx which is equal to sx. Okay, bx which is equal to sx. So what is the value for bx? Okay, so write down x here, take x as it is. This sx I written here. Okay, this sx here. Okay, so compare sx with this bx. Okay, so tell me the value for b, then sx which is equal to bx. This implies b which is equal to, okay, x can be cancelled, b which is equal to, we write here. So comparison of value I'll explain here, don't get confused. Now see that we want the value for b. Okay, to replacement a, b, this one a, this one a, this one b. Okay, so we have to replace a and b in our formulas. So compare sine bx dx with the sine sx ds. Okay, now with respect to this integration, we have ds as a we have ds as here as a with respect to sx integration. Okay, and we have with respect to sine bx, we are taking integration with respect to dx. Okay, that means x dx and s ds. Okay, s ds and x dx, that means we get the value for b as a x. What we have here, s ds. Okay, here we have s ds. Okay, x outside here, x s ds. Okay, s ds, x I taken outside. Similarly, check it here, bx dx. Okay, that means x dx, we will take a remaining coefficient out here, b out here. Okay, now see that s ds we have coefficient with the x, and x dx we have coefficient with the b. Okay, so this comparison, it is very much important, guys. Okay, so if you're going to take wrong value for b, your complete answer will be wrong. Okay, yes, so for that you must be very much careful while you are selecting value for b. Okay, so we have to take integration with respect to that variable. Okay, so using this variable we consider the value for b. Okay, so as we can see that x into s ds and b into x dx, so obviously we get the b as a x here. Okay, value for b as a x. So that means sine sx dx can be written as, we have the value for b as here ax and value for a as a, so now see that e raised to a into x compare as e raised to minus 1 into s. So we write a which is equal to minus 1, okay, bx and a minus 1. So replace a and b in our given formula, okay, in our formula. So what we get here, e raised to ax, okay, e raised to, what is the value for a, minus 1 minus x, okay, e raised to minus x upon a square plus b square. That means minus 1 square is a 1 square, okay, minus 1 square it is remain 1 plus b square means x square, okay. So minus 1 square plus x square it remain here, okay. That means e raised to minus x upon 1 plus x square. This is the this is the term for this our first one, okay. Go for the replacement of the next values. A sine bx. So replace the value for a which is minus 1 sine. So what is the value for b? B we have here x. And what is the value for x? Now we want the value for x also. Integration ds and dx is there na. Then we write x as a yes here. Sine x, yes, okay. I hope you all have understood how I have written, okay. Yes. So minus, what is the value for b? B we have here x, okay. I'm replacing only the values here. Don't get confused, guys. It is one of the easier, okay. Value for b which is the x here, cos bs, okay. Cos, what is the value for b? B again x. And what is the value for x? X we have here as a x. Now we want the value for x now. So ds and dx it is there. So we write x which is equal to yes. Okay, this one our next step, okay. That means we got the integration. Let me write integration minus yes sine yes x ds can be written as e raised to minus x upon 1 plus x square, okay, 1 plus x square under bracket minus sine yes x minus sine yes x minus x cos yes x, okay. This one is our complete integration of this step, okay. This step has this integration, okay. Now replace this value instead of it here, okay, and go for applying limit 0 to infinity and keep 2 by pi as it is here, okay. Yes, let me write in our next step. So f of x can be written as 2 by pi, okay. So we are going to apply limit as we have solved the integral here, okay. So e raised to minus x upon 1 plus x square, okay, under bracket minus sine sx minus x cos sx, okay. Yes, bracket complete, and we apply limit for this one as a 0 to infinity, okay, 0 to infinity, okay. So apply this limit. First of all, put infinity in our entire term, then minus, put 0 in our entire term. But where we have to put, as we are taking integration in the form of a ds, okay, as we are taking integration in the form of a ds here, so we have to replace wherever you get the s, okay, replace as infinity and 0 over here. So wherever yes it is there na, replace value, but we have e raised to minus 1 into yes na, it is not x, it is yes here. We are taking integration in the form of yes, okay. This one is e raised to minus yes, this one is e raised to minus yes, and this one is also e raised to minus yes, okay. So be careful with the variable, okay. This one is e raised to minus yes here, okay. So as we have e raised to as na, that's why e raised to minus yes it is here. When we have e raised to ax, we take e raised to ax it is here, okay. But we have, what we have here, e raised to as, then we write e raised to as, okay. That means minus yes as it is here, minus yes as it is here, and e raised to minus yes, okay. Now see that when we replace e raised to minus yes, okay, e raised to minus yes can be written as 1 upon e raised to yes, okay. I'm solving this one, okay, this variable here. E raised to minus yes can be written as 1 upon e raised to yes, okay. And when we replace yes as infinity, that means 1 upon e raised to infinity, okay. And 1 upon e raised to infinity means 1 upon infinity, and 1 upon infinity we have the value, it is a 0, okay. That means when we replace e raised to infinity minus infinity, we get the entire term, it is a 0, okay. So then we write 2 by pi 0 minus, that means e raised to minus yes, it is multiplicand to the entire step. So this one gives us the value 0. If this one is 0, so after multiplication of this entire step, it all goes to 0, Okay, yes. Now in next step, minus we replace s as a 0. So now see that e raised to minus 0 means 1. Okay, so we write 1 upon 1 plus x square. Yes, 1 upon 1 plus x square minus sine 0 into x. Sine 0, it means it is a 0. Okay, sine 0 into x means sine s into x means we replace s as a 0. Sine 0 into x, sine 0, it goes to 0, minus x cos s into x, cos 0, which gives us the value 1. Okay, and bracket complete. Okay, like this. So I just replace 0 here, cos 0, which is 1. Okay, yes. So 2 by pi keep as it is here. Okay, 2 by pi keep as it is, under bracket minus multiply this one. Okay, so minus 0, no need to write, minus x, minus and minus plus x. Okay, we write x upon 1 plus x square. Okay, this one is our small f of x. Okay, I hope you all have understood how this solution it is coming. Okay, now this one is our given integral equation. Okay, so solved form of integral equation that we have to solve here in our example. We have to solve this integral equation, and after solving this integral equation, I got this f of x here. Okay, yes, I hope you all have understood. It's nothing difficult, guys, one of the easy solution, but just need to be very much careful while you are selecting the formulas. Okay, so it is only calculation based part. I hope you all have understood entire my solution. So even after, if you have anything difficult, confusion here in my today's example, let me know in my comment section, guys. I will come up with the similar videos, and if you want to see more videos, let me know also in my comment section. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.